Okay, so after all that, what you're going to do is you want to summarize your data. So there are two ways of like summarizing your data. So one is called as descriptive statistics. So those are going to be what we're going to discuss in section 1.3. So I will leave that for now. But for now, we're going to talk about the graphical summary. Like, people love anything that is in graphic. So reading comics is so much fun than having to read books because there's no pictures. So the same goes for data. So people like to see charts, to see graphs rather than seeing a lot of data on the screen. Okay. So these are like an examples of graphical statistics that you can actually use for your data, and you are going to come across this over and over again when you work as well. It's not just going to be for studying purpose, but you're going to apply this somewhere in your job. So the first type of graphical statistics that is commonly seen as the histogram. Everyone loves histogram. And then we have frequency polygon. So if you have data that involve frequency, you might want to use this. And then we have OGIF, bar chart, Pareto chart, pie chart, and also time series graph. So time series graph is like when you wanted to do, like, you have data from 1998, 99, 2000, and so on. So this is when you use time series graph. Like, pie chart is a super convenient way to actually show data, as well as Pareto chart. Okay, so Pareto chart is actually a frequency chart, and it is marked in different colors to show different categories and so on. So bar chart and Pareto chart is a very popular one. Okay, so I will leave you to read this for your own, like what's good and what bad for each of this descriptive statistics. And histogram, frequency, polygon, and OGIF, they are being used for qualitative data. So I want you to go through very quickly, like what's good and what's bad about them. Okay, so distribution shape for histogram. So when you sketch a histogram, so the shape of the histogram can actually tell you things. And these are going to be the general shape, like the 8 most general shape that you might come across. So if you come across something that looks like this with a pick at the middle, so it's called as a bell shape. Remember what a bell is like? A bell is something like this. I know I'm really bad at sketching. So that's a bell, basically, and that's how a bell shape look like. And this is a uniform. It doesn't have to be exactly of the same height, but if they look like they have roughly the same height, so it's called as being uniform. So this is a J-shaped because it takes the J shape right here. Okay, and this is a reverse J shape, and this is called right skew. Right skew means that like the value here is higher, and when you go towards the right, it's tapered, it become lower. So it's called as being right skew. Become lower towards the right. So that is how you identify right skewed. And left skewed is when you go towards the left value, so it become tapered all over. So that is why I call it as being left skew. Okay, what is the difference between right skew and left skew? So right skew means that when you go towards higher value, so the frequency lowers. But for the case of left skew, so as the number increase, as the data value increase, so the frequency also increase. So that is what I mean by being left skewed. Bimodal, you have 2 picks. Okay, and the condition for bimodal is that these two, they must be the same height, then only it's going to become bimodal. If they are not the same, they're not bimodal, there's something else. And U-shape is because of the U-shape that looks like this. Okay, so it is a very common question for us to ask you, like what is the distribution shapes for the histogram. So you have to know this is like the 8 most basic ones. Okay, and if you have quantitative data, you can also use bar chart. You can also use Pareto chart if you have frequency distribution, and you can also use pie chart. Like, out of these 3, I think I use bar chart the most. Yeah, bar chart and Pareto chart is actually pretty much the same. Like bar chart, it doesn't have to be this way, so it could be this way as well. So it is up to you whether how are you going to turn around the axis. So this is called as this is the time series graph. You use this when you have time on the x-axis, right, and you wanted to see what happens over time gradually. So that is the purpose of time series graph. For example, You want to have a look at number of COVID cases since the first outbreak. What happened during the first month, second month, third month, fourth month. You want to see the pattern, so you can use the time series graph. This is called as stem and leaf plot. So what's good about the stem and leaf plot is that you can combine two data together. So this is going to be one data. For example, this could be data from male, this could come from female, and you can actually combine them together. So this is called as this is just a simple stem and leaf, and this one is called as back-to-back stem and leaf plot, right? And please read whatever description that you have over here and let me know if you have any problem. Yeah, this is like trying to match your type of data and what is going to be the best way to summarize that. So you might want to use this when you come across when you do your assignment later. So when you have a quantitative data, so if you want to describe it in one number, you could either use mean, median, mode. This is what we're going to discuss in the next subtopic. For graphical summary, you could either use histogram, bar chart, and so on. If you have symmetrical distribution, symmetrical means the bell shape distribution, so you could either use all these numbers or represent them as being histogram or bar chart and so on. Okay, so have a look at this. Presenting and analyzing the data. So analyzing the data, descriptive statistics, we're going to have a look at that in topic 1.3. Graphical summary, we have seen that before, so you could summarize your data in terms of graph and chart because that is going to be easiest for us to compare the data. Or like you also want to see, like if you have multiple variables, you also want to identify if there exists any relationship in the variable under study, and you want to make any relevant statistical inferences. In fact, all these three things that we have over here is going to be something that you're going to do in your assignment 1. So explore that later. Okay, so these are going to be the basic inferential statistics. So this is what we have going to discuss later from chapter 2 until chapter 6. And this is going to be advanced inferential statistics. So these are going to be the most basic ones that people usually use. But this is going to be the most the advanced one that for me, I usually being a statistical major, so I learned this during my master studies. So DOE, time series, multivariate, statistical quality control. So it's something that requires you with a lot of statistical concept, then only you can jump to this advanced inferential statistics. So you're not going to learn this. So you might learn this if you decide to pursue statistics in your studies later. Okay, and we also have statistical modeling, data mining,